Welcome to the Western Colorado Carbon Neutral Bioenergy Consortium, a partnership between Colorado State University, Colorado Mountain College, Flux Farm Foundation, and the City of Rifle. In 2009, Flux Farm received a research grant from the Colorado Department of Agriculture to conduct the consortium's first study, an evaluation of perennial plant species and production inputs for sustainable biomass and bioenergy production in western Colorado. During the spring of 2010, field preparation occurred at the group's 3 research locations in Carbondale, Rifle, and Fruita, Colorado. The standard agronomic practices of plowing, disking, cultipacking, and bedding were performed to ensure optimal germination. Soil sampling was conducted prior to crop planting to get baseline soil carbon data. Perennial grass crops have been shown to sequester carbon in soils and enhance soil quality. We intend to measure this performance over time. The USDA ARS is assisting with soil carbon analysis, and soils will be collected yearly. In the effort to produce low-input bioenergy crops, the group selected 4 grass entries for initial analysis: a native grass mix, an introduced pasture mix, a switchgrass mix, and a tall fescue monoculture. Irrigation has been limited to crop establishment, and varying amounts of fertilizer will be applied to plots in subsequent years to determine sustainable input levels. Our Fruita research location is also growing a Puncha prickly pear cactus. With the assistance of the Chinle Cactus Club and the Bureau of Land Management, 5 native varieties of Apuncha cactus were collected near Gateway, Colorado in the spring of 2010. Apuncha is interesting as a bioenergy feedstock since it requires little water and fertilizer and can grow well on very marginal soils. Little work has been done with cacti as a bioenergy crop in the United States, and we will test the performance of prickly pear cactus for conversion to fuel. Initial results look promising, and just after 3 months of growth, some of the cacti have doubled in size. In the effort to minimize crop inputs, grasses are harvested yearly after the first frost. After 1 growing season, the introduced pasture mix outperformed all other plantings significantly. Switchgrass produced the least amount of biomass. Results are as expected since many grasses require at least 1 full year to establish themselves. However, we suspect that cool season grasses will outperform warm season grasses in the region. Once the crops are harvested, they are sent to Colorado Mountain College's West Garfield campus in Rifle for conversion to butanol fuel. Over the past 6 months, a facility has been purposely constructed for the project, and equipment donations have been made by Encana, Williams Petroleum, Emerson Process Equipment, Shell, Airgas, Antero, C.H. Spencer, Chembre, Garfield Steel, and Bell Supply. Donations have included tanks, compressors, pumps, columns, and chromatographs. Once the demonstration facility is completed in March of 2011, it will have a value approaching $1 million and will be one of the first operational biobutanol processing facilities in the Intermountain West. We chose to produce butanol, a second-generation biofuel, over ethanol because of its higher energy density, lack of corrosive qualities, and ability to run unblended in existing vehicles. Fuel will be distributed to the City of Rifle for use in the city fleet. Data will also be collected to begin constructing economic performance and rural development opportunities. The project is fully integrated into the process engineering curriculum at CMC and gives students a hands-on opportunity to participate in a significant emerging industry. The consortium would like to thank the Colorado Department of Agriculture for financial and project support through the ACRE program. We look forward to future collaboration in bringing bioenergy opportunities to agriculture in western Colorado.